Asteroid mining. It's one of those ideas that sounds like it's straight out of science fiction, right? But believe it or not, it is getting closer to reality every single day. And it promises this incredible future of unimaginable wealth and clean resources. But it also has the potential to completely turn our world upside down. So let's really get into this. To really wrap your head around the scale we're talking about, just look at this one number: $700 quintillion. That's a 7 followed by 20 zeros. And that's just the estimated value of the gold locked inside a single asteroid, one called 16 Psyche. And that brings us right to the heart of the paradox here. Does tapping into this cosmic treasure chest kick off a golden age of prosperity for everyone? Or does it actually trigger a catastrophic economic collapse? That's the big question we're going to unpack. So, first up, let's look at the incredible promise, right? The utopian vision that is driving this whole new space race. I mean, why are we so obsessed with mining asteroids in the first place? Well, the hard truth is, mining here on Earth is a pretty brutal business. It often releases toxic stuff like lead and arsenic right into our environment. And in places like the Democratic Republic of the Congo, our demand for cobalt has fueled a horrifying crisis of child labor and fatal accidents. Space mining, at least in theory, offers a much cleaner, much more humane alternative, with access to resources that are, well, for all practical purposes, pretty much infinite. And the potential payoff, it is just mind-blowing. A database called Asteroid estimates that just the 10 most accessible asteroids could generate a profit of $1.5 trillion. And remember that asteroid 16 Psyche? It could, in theory, provide every single person on Earth with $93 billion worth of gold. You can see why people like astrophysicist Neil deGrasse Tyson are predicting that the world's first trillionaire is going to make their fortune in space. But okay, before we all start designing our personal space yachts, we have to face some immense, almost overwhelming challenges. This whole dream is grounded by some very, very harsh realities. Yeah, this slide right here puts a real-world price tag on all this ambition. To get just a tiny sample from the asteroid Bennu, NASA's OSIRIS-REx mission took 7 years and cost over $1 billion. And the projected return for all that? About 1 kilogram of material. Let that sink in. $1 billion for a kilogram. That shows you the scale of the technological and financial mountain we still have to climb. And this feeling isn't just among experts. It's pretty widespread. As one Reddit user put it pretty bluntly, large-scale profitable mining is probably 50 to 100 years out at least from being viable. There's just a huge gap between the dream and what we can actually do right now. And look, this isn't just a hypothetical problem. We've already seen this play out. Ambitious startups like Planetary Resources and Deep Space Industries, who, by the way, made huge contributions to the field, they ultimately couldn't handle the astronomical development costs and ended up getting acquired. The dream is incredibly expensive, and the road to get there is very, very long. Okay, but let's just imagine for a moment. Let's say we solve all of those technical and financial problems. We do it. We succeed. We bring back mountains of gold and platinum. Well, this is where the paradox really slams into reality, because success might just be the most dangerous outcome of them all. So really see the scale of this problem? Just look at platinum. In 2018, South Africa, the world's biggest producer, mined about $3.8 billion worth. Now compare that to the potential value of platinum on just one asteroid, $50 billion. A single rock in space could hold more tens than what our entire planet produces in a year. So what happens when you suddenly flood the market with that much supply? I mean, it's basic economics. Prices would absolutely plummet. One simulation from Tel Aviv University predicted a single shipment from space could slash gold prices in half. This would be devastating for developing nations like South Africa, Zimbabwe, and the DRC, whose economies depend heavily on exporting these minerals. Millions of mining jobs would just disappear. So, the researchers who ran that simulation, they didn't conclude we'd have a utopia of shared wealth. No. They said the result would be a significant global struggle for resources and power. The economic chaos could easily spill over into geopolitical chaos. So, we have this massive technological hurdle on one hand and an even bigger economic paradox on the other. How do you even begin to tackle a problem this complex? Well, some scientists think the answer might actually come from nature, with a concept called swarm intelligence. So this idea is called swarm intelligence. It's inspired by things like ant colonies or schools of fish. You see, there's no single leader calling all the shots. Instead, each individual agent, say a little robot or a drone, acts on its own, just following a few simple rules. But when they all interact, this complex, intelligent global behavior just kind of emerges. Now, this approach has three huge advantages that are basically perfect for space. Swarms are adaptable, which means they can react to changing, unpredictable environments. They're robust, so if a few of the robot agents fail, the whole mission doesn't just end. And they're scalable, meaning they can work well whether you have a few members or a whole lot of them. And here's the really cool part, what researchers call the swarm effect. In a well-designed swarm, the system becomes more than just the sum of its parts. As you add more members, the performance of the entire group and even each individual can actually go up. This superlinear scaling, that's the secret sauce that can make these huge, complex missions not just possible, but actually efficient. But, even the most brilliant technology can't solve the economic and political fallout all by itself. If this future is going to work for everyone, we're going to need a global plan. We need to bring everyone to the table. The Harvard International Review actually outlines a potential path forward. First, expand access to the technology so that developing nations can compete, not just get left behind. Second, actively help countries that rely on mining to diversify their economies now, before a crisis hits. Third, create a system where the nations that get rich from space mining compensate those that are harmed. And finally, and this might be the most important one, responsibly regulate production to avoid flooding the market and crashing prices. As the author of that article, Shreya Yarlagadda, puts it, this conversation can't just be for the countries with advanced space programs. It is high time to bring all countries to the asteroid mining table. Inclusivity isn't just some nice idea here. It's absolutely essential for global stability. So you see, this is no longer a question of if. It's really a question of how. The technology is developing. The resources are out there. The real challenge, it turns out, isn't up in space. It's right here on Earth. Will we have the foresight to actually design a future of shared prosperity? Or will this next gold rush just be a repeat of the same old mistakes, but on a cosmic scale?